for example 5 and then also example 6, we're working with piecewise functions, and piecewise functions are functions that are made up of more than one equation. So there are 3 in this problem right here. Technically, this first guy right here is f of x equal x plus 1, the second one would be f of x equal 5, and the third one would be f of x equals x squared. There are literally 3 equations right here, but they don't write f of x separately for each one of those equations because they're all counted as 1. And each one of these equations are going to have a different domain, which is the x values that you can plug in or substitute into each equation, and it also tells you where you're going to graph your functions if you were graphing on graph paper. That's example 6. So our first equation is f of x equal x plus 1, and the x's that you can plug into the problem or the domain is right here. I can substitute any x that is less than -2 into this equation. I can also only graph this on the graph paper for x's that are less than -2. So where you're going to graph and what numbers you're going to substitute in comes from this right here. And if I look at my list of my x values that I'm going to be plugging into this function, I can see that -5 is less than -2, and also -3 is less than -2. Now I like to actually sort out my numbers for these problems off to the side here, where or next to the equation that they're going to go into, but you don't really have to do that scratch work if you don't want to. Okay, so the next function, f of x equal 5, is going to have x's substitute into it that are in between -2 and 3 and including -2 and 3. And also on the graph paper, where we would graph that would be in between those 2 numbers as well. And anything in this list that is in between and including -2 to 3 would be 0 and 3. And then finally, f of x equal x squared is going to have the x's substitute into it that are greater than 3, which would be the 4 and the 10. So any x that is greater than 3, which would be 4 and 10 in the list down below, is going to go into that equation. Also, if I were graphing this on graph paper, I would only be able to graph it where the x values are greater than 3. Okay, so let's go ahead and do the first equation, which is going to use x plus 1. So we have x plus 1, and we're plugging in or substituting in a -5, and that equals -4 when it's cleaned up. So that one's done. And then we're going to do f of -3, which uses the same equation, x plus 1. Substitute in my -3, and I get -2. So that's done. Okay, now we're going to be using f of x equal -5. So I'm going to plug in a 0. Now there's an issue here because I don't really have an x to plug into. So even though it's telling me to put in a 0, I don't have a spot for it to substitute into. So I'm just going to copy down the rest of my function, which is just 5, and that literally is the answer. It's kind of already solved for. There's nowhere to put the 0 in for x, so whatever it was to start with, that's the answer. F of 0 equals 5. And the same thing is going to happen to this 3. When I try to plug in a 3, I don't really have a spot for it, so I'm just going to bring down what was already there. So there's nothing to calculate out because I don't have a place to plug in my x. And then we have 2 more to do. We have to do f of 4, and we need to use our x squared equation. So there's x squared, plug in a 4, and you get 16. And then that one's done. And then finally we have to plug in a 10 into x squared. And then our answer is 100.